Okay, yeah, like, so any questions? So,
Sir,
okay, yeah, please.
sir, can you explain the difference between kernel, system program, application program, and operating system?
Yeah, yeah, right, good. So that today you will make it more clearer. I just introduced the terminology in the last class, right? So I think today we'll spend more time on that, like exclusively on system programs, system calls, kernel, application programs. So all those things today we'll spend more time so that you will get more clarity on that. Yeah, appears to be like similar, but you can see the distinction or the uniqueness of each of them in today's class and all. We'll see that. Okay, so let me share the slide. Uh, so can you see the slide? Right?
Yes,
Hello.
sir.
Okay, slide, no? Right? Can you see? So is it? Can you see the slide?
Yes, sir. Yes, sir.
Okay. Yeah, good. So see that actually I just starting the now the chapter two. You see that I have not completed the chapter one in the last class. So then what I have done is that I recorded some video, the remaining portion of the chapter one, and then placed in the files. So please look into that. So that contains the remaining part. In the last class, in the last two lectures, we discussed about the briefly about the introduction part, and in that, basically, what we seen is that what we have observed in the discussion was operating system is kind of the interface or like is in between the user programs or users to the bare hardware or the computer the hardware hardware. So in that perspective it has to deal with both the hardware aspects of the system, and at the same time it has to deal with the user requests or the user requirements also. So therefore, coming to the objectives or the goals of operating system, it has to satisfy or it has to play an intermediate role for satisfying both the user goals or user requirements. Like basically user requirements means the user programs, they had to run the execute the user programs in a satisfactory manner as per the requirements, right? And the same way, whatever the bottom or the bare hardware, whatever is there, and that has to also take care about the using that hardware. It has to take care about it has to execute the user programs in an efficient way. So from that perspective, when you are discussing an introductory chapter, since the operating system, the role or objectives that depends on the even the computer hardware, all right. So from that perspective, we discussed about what is the overall the block diagram of computer, and what are the different entities it contains and all. And among that we have gone to the details also, like in case of take the CPU and all, what are the how the computers vary with respect to the CPU, single CPU or multiprocessor CPU and so on. And likewise, then going to the memory and also what are the different types of memories it contains, and then the storage system, what is the storage hierarchy. So all those details we discussed. Then the file system, which provides the abstract view of information. It may present in the various devices. It may be the disk, or it may be a floppy disk, or it may be some other magnetic tape, or whatever. So those details we had discussed in detail. And we also discussed about very briefly about how the operating system will handle the communication between the different entities in a computer, for example, from the various peripherals to the CPU or a memory and so on, or from the user to the various peripherals. So those things very briefly we discussed. And due to lack of time, I'm not able to cover, I'm not able to discuss those things, like as I mentioned. And having said that, the operating, having discussed about computer systems and all, and where these computer systems are used, like what are the environments where these computer systems are used, whether these are used at the, like as a personal computer at a at a home appliances, or at a personal computer level, or at a distributed environment, like where they are connected through network at which are lying at different places and all. And or in the other way, like in the other environments, like a kind of client server or a web server and a client paradigm, or peer-to-peer computing. So it means that computers can act as both server as well as a client also. And so these are the different environments where, based on that, the operating system also has to have to deliver the services accordingly. So these are the various things that come under that as a part of the introduction. In that, most of them we have covered, and some of them, whichever I have not covered. So those things I recorded a video and then placed in the files under voice. You can look into that. So, and next, I'm just moving on to the this chapter, the next chapter, and this is also partly the mostly the introduction. And once if we cover this, and then we can move on to the detailed aspects of the functionalities of OS at a different classes or different types of services it provides and all. So please go through that recorded video, and then the corresponding slides and all, so that you can make it, you can able to follow that. And if you have any queries and all, you can discuss that in the next class and all. It's not a problem. Hmm. Then coming to the today's class, we'll try to discuss about basically, first we'll discuss about the operating system services. That means what are the services that are provided by the operating system. We discussed that, we just covered these things very briefly in the last two lectures and all. And here we'll try to give a slightly more detailed version of that in the first lecture. Today's among the two lectures, the first lecture will try to very briefly discuss about the services provided by the operating system. And basically, as I mentioned, the operating system will provide the services both from the user perspective and as well in the from a system perspective also. And here we'll discuss about basically more of like from user perspective. Those services we'll discuss slightly detailed fashion. And after that, for performing all these services and all, like how to design an operating system. Like, because as you see that today, as we go on, we can able to see that what are the various types of services, various occasions where how the operating system will be intervened, or how operating system will be used by the user programs as well as from the system point of view also. So to take care about or to provide all these things, so how to design the operating system, because after all it's again a software or it's a program. So how to design that, how to make sure that having operating system to perform to carry out the various services, how do you how you design that, how to write a code for that. So how to design that and how to implement that. So these things also very briefly we'll discuss with some examples which are evolved over a period of time, like starting from, hello, yeah, yeah, starting from very the beginning, like MS DOS operating system, which is at the beginning it was meant for single user system. That means only one program used to run on the system and all. So then afterwards the multi-user, then multitasking, then several things have come up. So these things we'll discuss very briefly about how it was evolved, how the design will be, what is the reasonable design, better way, and these things we'll try to discuss. And we don't discuss much about the other something like virtual machines and all. Just give you the very brief when you're designing, when you're discussing about the structure of an operating system. At that point, we'll just mention that what is meant by virtual machine and all. Other than that, we don't go into the details. Then the final aspects of these things also, like what is meant by debugging in the context of operating system, and what is the operating system generation, right? So we'll see that what is meant by operating system generation and the system boot. So these things we discuss system boot and all in the last chapter, but again we'll revisit that. So we'll go into the details, and here coming to the objectives of operating system we discussed, and here like it describe the services of the operating system provide to the users, processes, and other systems and all. And here for these to carry out these services, so how the operating system will be structured. That means when you're designing the operating system, how the operating system will be structured, like. And then finally we'll discuss about the after having operating system, how do you install that, customize that, and how it will be reboot, how it will be booted. So these are the various things we'll try to discuss. And here basically in this particular chapter, we'll basically discuss about some important services the system provides, operating system provides. And the second one is that how the design the operating system, that means how the operating system will be structured to carry out these particular services and all, various services. So these are the two broad objectives that will be covered in this chapter as well in these two lectures and all. Yeah, and then coming to the operating system services, as I mentioned, basically the system operating system is meant for providing an environment to run or to execute the user programs and services to the programs and users and all, right? We'll see the details, more of them. So when you look at the operating system, as I mentioned that it provides the services from user perspective and from a system perspective also. So that way, one set of operating system services provide the functions that are helpful for the user, as I mentioned. And they are like here, the given below. So one is the user interface. So the operating system provide an interface to the user such that so that the user can able to conveniently run his user programs or conveniently use the system for running the user programs and all. So for that, in that context, we'll just briefly mention about the different types of the interfaces the operating system provides, various operating systems are providing, like command line interface, graphical user interface, and batch interface. So these are the three different types of interfaces. We'll very briefly discuss about each of them. And even though we may not know about this terminology, but we are using these things when you are using a system and all automatically. We'll see these details. What about basically we'll see the what is the distinction between these three interfaces and all. So that we'll see a bit later. And the second one is that the another service the operating system provides from a user perspective is that basically a program execution, because the user will program execution nothing but the applications, running the applications on the system and all. So for program execution, that means the system must, for if you want to execute a program, first of all, the program has to be loaded into a memory and then has to be run. And then after running the program, it has to somewhere at the some point of a time, the execution should be end. And this ending of execution will be either it may be normal termination. That means when it reaches to the last point of the program or the last instruction of a program, when it executes, then afterwards there is nothing, then the program will be like the exit automatically, normal way, or otherwise abnormal way. That means when you are executing a program at some point of a time because of some malfunctioning or some abnormality or some error because of the like various types of errors like division by zero, or like the when you're performing certain operation where the number of bits may not be sufficient. So that way the program may terminate in a different ways. And then IO operations, like when they're running a program, it may require the IO, and that IO may be from the file or from the IO device. Hmm? Right? And then the file system manipulation. So it means a file system, that means the user when running the programs and all, it need to modify or manipulate the files in a different ways, like reading the file, writing the file, directories, creating deletion, and searching a file, searching the content within a file and all. So these are the various the services that are provided in the context of the file manipulation. So all these are related to the like from a, that means user can able to see these services or see these from the operating system. And likewise, communications. So when the program is executing, sometimes the program need to exchange information with some other process. Sorry, not program, same, it's a process, right? Program in execution is known to be a process, right? The program is nothing but it's a bare the list of instructions and all. So the process may need to exchange information when it's execution and all. And the kind of execute this exchange of information may be that a process may be within the same system, or the process may be on a system where that system is connected external to the system. That is, system is connected via network and all. So that means basically it's like communication. That means a process can communicate with other process. So though that other process may be within a system, within the same computer, or maybe external to that. So in that case, how do you perform that? Like what the operating system will provide that service using different techniques known to be shared memory technique and a message passing techniques and all. We'll see that. And then another service provided by operating system was error detection, right? When the program is the execution, when the program is in execution, or when the computer is running the program, so there is chances of occurring errors at different points, at different places. Like the programs, the error may occur in the CPU, or error may occur in the memory itself, like when you are trying to access the memory location where it is beyond the program, process defined memory, or when it's executing the illegal instruction, or the IO devices, mm, or in the user program itself. So there are chances of errors that may happen at anywhere within the CPU, or in the memory itself, or in the IO devices, or in the user program itself, right? So, and for each type of error, the OS should take care about providing an appropriate action, and it should ensure the correct and consistent computing and all, right? So that is the job of the OS, right? And then the debugging also facilities also can be used by the OS so that it can enhance the users and programs the abilities and all. So the debugging means actually to ensure that the program whatever is written, how the execution takes place, because when it's normal execution you cannot see those the details and all. So therefore, if you want to see the details of program execution, like in a sequence, or like instruction by instruction from user point of view, you can do that by using the debugging facility. So with that, you can come to know the how the program is, how the flow of the data, or how the program, these things are varying and all. So all these are the part of the services provided by the OS from the user viewpoint. And then coming to the services provided that are from the system perspective, it's nothing but like efficient operation of the system by using the resource sharing. And as you know that these things is like resource allocation means when you are using a multiple users or multiple process which are running concurrently, and the resources must be shared in a fair manner. So here the context, the resources means basically the CPU, memory, IO devices, file system, and so on. These are the various resources. So when a program is execution, then it needs these resources. These resources will be needed by the program execution. Because to run the program, to interpret the instructions, to run the execution instructions and all, you need the CPU cycle. CPU time is required. So that way the CPU cycles and the memory, the file storage. So these are the various resources that need to be allocated to the process. And since there are multiple processes and the resources may be limited, so in that case, how to allocate the resources in a fair way for optimizing the managing the resources in an effective way, like in a different perspective, from a user perspective and from a system perspective also. And then the accounting, so this is also like it basically indicates that keeps track of the users or the processes, like which of the process is using what resources, how much time it is using. So this is for keeping track of that one. You can use this. So this is also a service provided by the operating system and all. And so this may have the different things, because by knowing that, by analyzing the this data, the statistical data of this one. So we can come to know, we can able to analyze the which processes are utilizing the resources, and also from that we can able to identify the bottlenecks, the problems in the performance. If the performance is not up to mark, then by analyzing these details and all, you can come to know, you can figure it out where the problem is, why the performance is not up to the mark. Likewise, the protection and security. So these things we discussed, because the onus of the information. Suppose you created some process, you created a file and all, and then it has to ensure that, because since these things are there in the multi-user environment or a networked environment, then it has to make sure that the information that was created should be protected from the other users and all, and it has to give the access in a systematic way, so that desired protection will be ensured, right? So access to the system resources is controlled by using the appropriately by the operating system. And security means like you can say that you have to make sure that there will be attacks from the inside or outside, and from that you need to make sure that the files whatever generated or the resources whatever should be protected. So that way, a kind of user authentication and the other secured measures will be taken care. That is also part of the operating system. So these are the things, whatever the resource allocation, accounting, protection, security. So these are the certain services that are from the viewpoint of the system, right? So that way, at a gross level, you can say that the operating system will provide the services, like some of them are the user perspective, some of them are the system perspective, some will be like you can able to analyze it, you can able to view them in the both the perspectives. And this is the overall the view of operating system services that are provided. So here at the bottom we have the hardware system, and at the very top it will be your the user programs and all. And here in between you have the, you can say this is the whole thing. I cannot say it's operating system. Here you can say that you see that there is the user programs, they use the operating system. For that they make use of the operating system will provide the user interface, and that user interface may be one of these types, as I mentioned, like either the command line interface or batch interface or a graphical user interface. There are different types of interfaces. By using one of these interface, the user programs will make use of the system through the operating system services and all. And here, the blue box, the bigger one, indicating the operating system services. What are the various services that the operating system will offer to the system as well as to the users and all. Like the ones whatever I just mentioned just now, like program execution, all these things and all. And for using these services, the user programs will make use of these services using a system calls. Using a system calls. So this is the system call interface. So with this system call interface, the user programs will use the operating system services through this particular interface and all. So these are the system call. That means system calls are nothing but just there are the functions which are associated or which will perform the services of the operating system and all, like all these things, whatever the program execution and all these things, right? And then here this is the hardware. So we'll see the details of that. You can see a clarity on what is system call, what is a system program, and what is this the interface, user interface, and what are these. So these things you can able to see a detailed, get a more clarity in the next further slides and all. Yeah, first we'll discuss about these interfaces, different interfaces. And so, as I mentioned, there are three types of interfaces. One of them is a command line interface, and it's also known to be command interpreter. So these you might have uh, experienced in the systems and all. You have a window where you have some command prompt used to be there, like a dollar sign or some other sign. And with that, where here in this interface, where the user has to enter a command, and then the command will be run at that prompt and all. The command will be run at that prompt. So here, This is here, in this case, the interface is just a very simple one, just to have a window where you have a dollar prompt and where the user has to enter the commands, and through commands he has to run the programs. Through the commands he has to run the pro. You might have seen when you're, suppose for example, you wrote a C program, for example, you want to compile that or you want to execute that C program, where if you have a command line interface at the prompt, you write that you need to give the command, your program, and then you have to compile that using the appropriate compiler, C compiler, and then it generates the executable file, and afterwards you need to run that executable file. So all these things you can able to do it from the command line interface. It is the one where it just provides a like a normal just a kind of window where you can able to, the user has to remember, he has to run the programs or run in the form of commands and all. So it means that he has to give a command. A command here, the command is nothing but it's a kind of a program, a piece of program. And when you give that program, then whatever that command contains, whatever the instructions, whatever they are inside that, so they will be executed and all. So that way here, this is a simple interface, command line interface, where the user will directly enter the commands and all. User will directly enter the commands, and you can able to see that from your systems and all at the command line interface if you open, or in the normal even Unix also you have a command window will be there, and if you open that, and then from that you can able to feed the commands, provide the commands, and then when you press the enter button, you can able to see that the command will be executed and all, right? So this is the command line interface, interpreter or command line interface, and where these things, this CLI, the command line interface. So these will be sometimes, mostly it is implemented through a system program, and sometimes it will be a part of a kernel also. That means giving that window and then execution of that command, whatever is given by the user, and also that thing will be sometimes, very rarely it will be a part of a kernel, the actual operating system, or otherwise mostly it will be a part of a system program. Part of a system program. So part of a system program means it's not in the kernel. It's not the actual core part of the operating system and all. It's again a program. It's again a program, but these programs are very frequently used by the multiple users. So that's why this is known to be system program and all. We'll see that again, the details of that. So what I mean to say is that the command line interface provides the interface to the user where he can able to run the programs and all. And for that here in this interface where the programs will be run by giving the commands by the user and all. That means, for example, if you want to see the files, whatever is there, or see the files that are there in the system and all, then by using appropriate command like ls, you can able to see what are the directories that were there in the particular system and all. And likewise, by giving the further commands, you can able to see that in that particular directory, what are the various files are there, what are the contents, and what is the length of the file. So by giving the different attributes to that particular command, you can able to get the different views or different information and all, right? So that way the command line interface will provide the user a command window, and with that, in that window, when the user enters the commands, and you can able to see that means it will interpret and it can run the command. So with that, the user can able to see the outcome as per the command he has given and all. And so, yeah, as I mentioned, the CLI command line interface, that means the overall interface. So that will be like as a part of a kernel, or it is a part of a system program. We'll see that what is the difference between these two and all, right? Yeah. Uh, then these CLI, these command line interfaces, maybe have the different flavors. Like those who are have familiar with that, actually, in the case of Unix system and other things, we have different types of shells will be there. The shell is nothing but it's a one flavor of a command line interface. That means it can have certain set of commands. So with that, you can able to get the information. You can able to run the programs and all. Like you have B shell, C shell, K shell. We have different types of shells will be there, and they will provide the different environments for the user to run the programs and all. Other than that, there is nothing different and all. And So this is the shell, and then primarily this command line interface. It's kind of, as I mentioned, it's primarily a command from the user executes it, and sometimes these commands are built in. Built in means as a part of the system itself, or otherwise even the user can also write this his own programs and can able to add like a commands into that. So this is a simple command line interface. We'll see that how it used to be. And the other one is the GUI, graphical user interface. And this is the one what most of us are very familiar with that interface. And so the GUI is nothing but the ones whatever we are when you are using your personal computer and all, you are accessing the system by using the GUI. So here it's nothing but it provides a friendly desktop where interface which contains the like different icons, and these icons represent the files, programs, and different things. And then you can able to access these icons using a mouse or keyboard and other things, right? And with that, actually, by clicking the icons with a mouse, then you can able to open the files. You can able to like create a directories. So several things you can able to do it, and this is more user friendly compared to the command line interface, because in command line interface there is nothing. You can have a simple empty window will be created for you. The interface will provide for you, and then at the user at the prompt, at that specific prompt where you need to enter the command, and then when you enter the command, and then the command will be executed. So in that case, actually, you should have some kind of a familiarity or some kind of the commands has to be remembered. Then only you can able to execute the programs and all. And so whereas in case of a graphical user interface, so all these things, the commands, instead of remembering or instead of knowing the commands and all, so most of the things, whatever is most frequently required, so all those things will be placed in the form of icons on the screen, and then by using a mouse clicks, you can able to execute those the programs or files or whatever and all. So that's whatever we are right now, we are the way we are like accessing the system is by using this graphical user interface, right? So this is the graphical user interface, where the difference is that in case of command line interface, where you have some set of commands will be there, and those commands has to be placed or entered in the window, and you need to execute that. So for every action, for whatever you want to do, you need that will be in the form of a command you need to enter, and then it will run, and you can able to get some output. And here in case of a GUI, so in place of those commands and also all those things will be placed in the form of like like in the form of icons, and with the different symbols and different names and other things, and with the different menus, where by clicking the menu you'll get a menu bar with the different options you can select. So that way this is a more user friendly. You don't need to remember the various commands and other things. So that way this is another way of interface where with which you can able to access the system, or access the system is nothing but with which you can able to access the computer for execution of programs and other things. And so these are some of the examples where some operating systems will support both of them, most of them right now, both the command line interface as well as the GUI. It will support both of them, most of them. Like the present operating system supports both, because sometimes when you are running the program at that time, due to some problem, if the GUI is unable to open, at that time the command line interface will be useful, because the command line interface and all, it just very offers a simple service, just provides the window where you can able to enter the commands, you can able to run, and with that, if there are any problems at the beginning startup, you can able to resolve using the CLI command line interface and all. That means with which the user can directly enter, can see the problem, can able to see the things, what are why the like this normal GUI is not coming up. So other, even other details also, the startup details, all these things you can come to know. For that purpose, both the CLI and GUI will be there in the normal, in the present operating systems. And then coming to the batch operating system, I have not mentioned here. The batch operating system is basically, it's not operating system, batch interface, where it is used the not at present we are not familiar with that. And here, in case of batch interface, the idea is that It's similar to command line interface, but here in case of batch interface, where the batch of jobs or the set of commands can be put together in one file and you can able to run them. So basically the batch interface is mainly meant for where if you are running the program, if you are using a computer for the jobs where where there doesn't need much user interaction or user interface, right? User interaction is not required. In that case, you can use the batch interface and all. Like yeah, as I mentioned, like for example, you have some servers and all where in the normal time you can use it for running a normal applications, and during the other times where if you're not using, then at that time for running the background processes and other things, you can use a batch interface where with that whatever the list of the jobs that need to be performed, you can put it all of them packed, and then you can able to run it. So that way, the batch interface will be used for running the jobs which doesn't need the much user interaction or user interface. So that purpose, you can use the batch interface and all. And mostly they are used at the earlier times, like at the initial times when the computers are used. At that time, the jobs or the systems that are required, that are not much require the user interaction and all. So for them, most of the things, whatever the data, the inputs that are required, they will provide at the time of submitting the job itself, and then we'll provide the set of jobs together, and then the system will run one after the another. So that is kind of a batch interface and all. So right now we are not much familiar with that. We are not using that. So these are the three different interfaces. One is the command line interface, which is a very simpler one, and where you need to like provide the user has to enter the commands, and the system will run. That means the operating system will provide the command to run by the system, and it gives you the output. And whereas the GUI is that instead of commands, they will be shown that they will be represented in the form of icons. And then these icons will be operated by using a mouse or keyboard and so on. And with that, you can do that, right? And the batch interface is nothing but there is no need for not much user interaction is required. So therefore, the set of jobs will be placed and it will be run together. So those are the three different user interfaces, right? And so user interface means here for running the user applications, the computer, the way you need to interact with the computer, there are this is the way like earlier systems and all they use the command line interface or the batch interface, and now the systems mostly the systems are used by the people very for their personal applications, and lots of applications, lot of interaction is required. So in that case, we are using this GUI, and the GUI is more convenient compared to the command line interface or the batch interface. So that way, these are the three different types of interface, and now you have much more. You can see that in case of nowadays, in case for mobile devices, they are also computing mostly, and these are like now you have the touch interface will be there. Here, the way that you interact the system will be mostly you have icons, but instead of mouse and other clicks and all, you can use your touch with the finger touch itself. You can able to carry out the desired task and also that way this is another type of interface. And likewise the interface is like now you have some voice commands, with that itself you can able to carry out certain tasks, and also that way there are now the advanced interfaces are there, but these are the ones which are the ones that are basic. In that the GUI is the more popular and the user friendly interface. Okay, so these are some of the examples of the interfaces, whatever I mentioned. Command line interface with the shell, not to be bound shell. As I mentioned, like Unix will provide different flavors in these command line interfaces, like by offering different shells, like a bound shell is one of them. Likewise, the C shell, like a K shell. So likewise, we have various shells where each shell will offer different flavors. That means it will provide the different commands. With that commands, you can able to perform various tasks, various varieties of tasks and all. And these shells mostly they are not the part of the kernel. They are the system programs. And that means they will in turn will make use of the kernel routines or the kernel functionalities and all. We'll see that later. But basically, the Unix will use these shell programs or shells which are outside the kernel. They are the system programs basically. So here, this is the way the command window will be there, and then yeah, something like, yeah, you can see the prompt here and all. Like here, the hash symbol, some shells and all, they provide the dollar symbol and all. So with that, if you type a command, for example, then uptime, for example, here, then it provides certain information, whatever. And likewise, you have the different by providing different commands, it used to give the information related to that. Hmm. And so these are the windows like graphical user interface and all provided by different icons. And by clicking that, you can pop up different windows and different menus and all. And you can able to select it by using the either keyboard or by using a menu by using the mouse clicks. Hmm. Yeah. Then coming to the next thing in the yeah, it will be a system calls. And here, if you see that, if you look at that, the overall the this figure, we discussed about these interfaces, right? And basically, these interfaces are nothing but the users want to interact with the computer or want to use the computer. For that purpose, the operating system will provide different types of interfaces. These interfaces will provide the environment, a kind of environment with which the users can carry out their applications, right? Can run their programs and so on. And so for that purpose, we just mentioned about different types of interfaces like command line interface, GUI, and so on. So these are the different types of interfaces, right? And the next thing is that the below that is the system calls. And this is actually the system call interface, whatever here is mentioned here. And system calls are nothing but they are like functions, like the way we write the user programs will write the program in the form of functions. The same way in the case of operating system also, to perform its functionality, the code will be in the form of different functions and all. And then based on the user program, the request, and the specific function or the specific function will be called and it will be executed and all. So that way, since these are the operating system functions and they will be called with user program, so these are known to be system calls and all. That means the user program will make use of the operating system services using a system calls and all. System call is nothing but just calling a function. Like in the case of normal, when you write a code program, where the entire your task is divided into different subtasks. Each task will be, you realize that in the form of functions, and based on the requirement, we will call the appropriate function and all. The same way here also, the user program, when it requires any of the system, when the process of execution, it needs the system's resources and all, or it needs certain services, and where that services will be offered by the operating system by using its operating system functions. And for that functions, it will call those functions using the system calls and all. So we'll see that when you look into it, you can, yeah. So it basically it provides a programming interface to the services provided by the operating system and all, because the operating system will provide varieties of services and all. So the operating system will provide an interface to the user programs, like an interface where by using the system calls, the user programs can access the operating system services and all, right? And usually the system calls will be written in the form of high level language like C or C++. And and mostly they are accessed by the programs via the high level language application program interface. It means that what I mean to say is that the user programs, they don't directly interact, they don't directly call the system calls directly. So instead, actually, there is some application API, don't application programming interface. It provides a set of, yeah, hello. Yeah, please mute. Yeah, students. Yeah, please mute yourself. Yeah, good. Yeah. So here, the system calls are not directly called, are not directly used by the user programs directly. Instead, The user programs will access the system calls through the application programming interface. Application programming interface is nothing but it provides a kind of library, a kind of set of functions, and these functions will be directly used by the user program, and these functions will indirectly call inside the desired system call and all. So that way, the application programs will make use of this API, application programming interface. With that, they will interact or they will access the system calls and all. So for that purpose, like there are three well-known APIs supported by the different operating systems, like Win32 API for Windows, POSIX API for the Unix, Linux, and Mac OS, and a Java API for JVM, Java Virtual Machine. So these are the different APIs with which the programmers will make use of the system calls through these APIs and all. And yeah, the thing is that why the APIs are used instead of directly system calls and all. The reason is that basically, if you have the APIs and all, so they are like portability will be improved. Like you can able to, if you go to any system and all, if you want to use the system calls, you need not know about the system calls. If you have the appropriate API and if a program runs on that API, then you can able to execute that program using that. And another thing is that knowing the system calls will be handling the system calls like the parameters, arguments, and all those things and all a bit tough compared to the APIs and all. So therefore, usually mostly the APIs will be used for handling for calling the system, these system operating system routines and all. So we'll see the example how the system calls look like, for example. So you can see that just take a simple example where suppose you want to copy a file from a source to some other destination file, for example, or you want to transfer the contents or copy the contents of from source file to some destination file. For doing that, you can able to see that how many times the operating system will intervene or what are the various operating system services it provides. You can able to see that it's just because we see that we do these many times in our normal usage of system and all. And for doing this simple copying a file, it requires, you see that how many system calls it requires and all. So first of all, if you want to copy a file from source to destination, what you need to do is that first of all, you should acquire the input file name. That means so for doing that, you need to have write prompt on your screen. And then afterwards, you need to accept the input. You see that just for capturing the input file name, you need to have these 2, 3 system calls are required because for that means you need to enter the input, so file name. So therefore, you need to have write prompt. So therefore, some display message has to be placed. That is a system call again because you have to use the display device, and then afterwards you need to enter the input so through keyboard or whatever. That is again one more system call, and then afterwards the same way you need to do for the output file name also, right? So once you have the input and output file names, then you have to open the file input file. So for opening input file again you have system call, and if the file exists then it's fine. Otherwise you need to display a message, error message saying that file doesn't exist or something like that about. Similarly for output file also, right? If the file exists then fine, if the doesn't exist abort. And then afterwards, once the input or output files are available, then you start the copying. You start the copying the contents from source to destination. For that, again, you need to copy a certain amount that depending on the system and other things, like a certain quantum or like certain block of data will be copied. So for copying every block, you need to have a read and write operations are required. You need to read the content from source file, and again you have to write into that. And so that way you have to perform this read write multiple times till it reach the end of the file, till you reach the end of the file, the end of the source file and all. So that way, and afterwards, once you have done that, then you need to close the file, both input and output file. So that way you see that for just copying the contents from one file to other file, you need to come across, you need to execute a lot of system calls. Here these are known to be system calls, like, because for all these activities that will be carried out by the operating system functions, by the operating system function, for opening a file or for closing the file, for reading the file, writing the file, right? And like displaying the message and capturing the input file name. So you see that there are several lots of operating system functions need to be carried out for performing like copying a file from source to destination file and all. So these are the like all these functions will be performed by using a sequence of system calls, and all, right? So all these are different system calls. One system call is that for displaying a message on the display, and another system call is that accepting the file name, and another system call is that whether it has to check that whether file exists or not. If the file doesn't exist, for example, then it has to throw in an error message. So that is again a system call. So likewise, and then it has to read the content, write the content into the file, and that it has to do the several times, that depending upon the block size and all. So you see that there are several system calls that system function or operating system functions has to be executed to perform this particular task of copying a file and all, right? And yeah, right. For doing that, as I mentioned that for performing these system calls, as I mentioned that it will be carried out through the API, application programming interface. It means that, for example, you want to read a file, for example, then this is uh, the function that is supported by the API. That is read file brackets, where it has certain argument it expects and all. And if you provide that, then this particular API, this particular function call, it will indirectly call the appropriate system call, and it will perform the read operation and all, right? So that way, for every system call, the user program or the user doesn't need to know about the structure of a system call and all. The user has to know about the corresponding API, the function, and with that API, you can able to call the desired system call, and that system call will be executed and all. And so now you see that how the system call will be actually implemented. So the way, as I already mentioned that, so the system call, like here, all the each system call will be associated with a number, specific number. And for example, your operating system supports, for example, 100 system calls, for example, then sorry, 100 functions were there, assuming that, and these functions, all these functions will be like numbered, like 1 to 100 kind of a thing. And then all the system calls will be maintained. System calls is nothing, when I say system call means it's nothing but a function. It's nothing but a function which is in the kernel, or which is a part of the operating system and all. And likewise, so for every function you have associated with a system call, and such functions, all these functions have the specific unique ID will be there. And then the system call interface, as I mentioned, it just maintains the table, and where the table is indexed by this call number, system call number and all. Suppose, as I mentioned, that suppose you have some 100 functions are there, then there are 100 system calls, and which are indexed, which are placed in the system call table. And the system call table is indexed by the system call numbers, and the table contains the index of the system call, nothing but identity of a system call. And then against to the identity, wherever the system call is placed in the memory, the starting location or the starting address of that particular system call will be there in the table and all, right? The operating system will maintain a system call table, system call interface, and it's nothing but it's a table, and where the table is indexed with the system call numbers, and against to that number, where it maintains the address of the particular system call, the address of the particular, because the system call will be there in the kernel, and the kernel is there in the memory, main memory, and then wherever that particular system call there in the memory, the starting address of that particular memory location, and that address will be placed against to that particular system call, the index and all. So that way the operating system maintains a system call table, right? And then the each entry of the system call table contains the starting address of that particular specific system calls and all. So that way you can say that the system call interface invokes the, yeah, that way. So whenever the user program requires the desired IO or desired service of this operating system, then the user will use the appropriate API function, application program interface with appropriate function, and with that he will call that function. That means he will use that function call in his user program, and that particular function call will internally it will call the corresponding system call and all, the corresponding system call, and then that way the user programs will will make use of the system calls to carry out their various services and all. So that way the user doesn't know about the system calls, the details and all. He has to know about only the API. That means the function supported by the application program interface, and that provides the services, whatever the services offered by the operating system, and those services will be accessed using the API and corresponding API. So let's see the
I had a
example.
doubt.
Yeah, please. Yeah, please, please.
Sir, in system calls, the calls are made like in a stack, right?
Not system calls are made.
The calls are like the data are kept like they keep incoming in a stack, right? Like
No, stack. Yeah, stack is yeah, stack. Use the stack and all, but it's not incoming in the stack. And all. We'll see that they can able to get it clarified in the later
sir,
slides and all. How to use? Yeah, tell me.
sir, if there are too many number of system calls that are in a pipeline, then what would happen? Like, is there any abortion mechanism?
No. It's not. No, you can see that as we have seen earlier, there is not like the system calls are in a pipeline kind of a thing, because at any point of a time, let us make the things simpler. For example, in case of a single processor system and all, only one processor will be there. So therefore, only one execution will takes place. Maybe it supports the multi-program and multi-user and all, but only one
Yes.
program will takes place. Certainly, only one program execution will takes place and all, right? So at that for that particular program, if it needs any IO or anything, any system call, then it calls the corresponding API function, application programming function, and with that that function will call the system call internally, and then the system call will be executed.
Yes, sir. What happens if like there is a
And
delay or if the response is too
exactly, yeah, exactly. For example, if that particular system call has to wait for certain thing, for example, suppose the particular system call, whatever the user program is requesting, it need to access the disk, for example, or it need to get the content from the disk, for example. So at that time, what happens? At that time, this particular system call, right? So it will be waiting for the disk. It will be waiting for that disk, right? And then the next then at that time the user program will not wait, or this even the kernel routine also will not wait for that. So then the CPU will be given access for some other program. So
okay.
then this
So
particular system call will be like waiting for that particular thing.
okay.
That
So
way it
this
happens.
acts as the watchdog here, right?
Huh?
So the CPU will act as the watchdog here. Like it will put a timer and
No,
try to
no,
understand.
not CPU will put the timer under that. Again, they're taken care by the operating system and all. The CPU will not wait for that. See that
Okay.
CPU is a device, hardware. It doesn't know about what is happening by what and all. It just whatever the instruction given to that, it tries to execute that. That's all. Right.
Yes, sir.
So again, that operating system will do that. Again, the operating system, the some timer will be set for that waiting time or whatever. So that way, the timer, that operating system will take care of that. And again, the operating system, how it will do? Again, it use some other routine, and again, it will be executed by the CPU. So that way, the things will happen and all.
Okay.
Right.
So sir, like caching and buffering, they are primarily done by the CPU. So here system calls are primarily done by the operating system, not by the CPU, right?
No. System calls are like those are the programs that are there in the kernel. And again,
Yes.
those system calls are executed by the CPU, because any program, anything has to be executed by the CPU, right?
Yes. But they're
Yeah,
called by the like
they're called by the
CPU role
they
in
are called by they are called by the yeah they are called by the user programs, right? For example, as you see, as a simple case, when the user program is executing and you have a scanf function or you have printf function, for example. So you are calling a system call. That means the scanf function is nothing but it's a library function. Indirectly, you need the operating system to access that particular functionality. So therefore, you are calling a system call that we are calling the operating system routine. And for that, you are using the scanf function. That scanf function is a library function where that indirectly calls the system call. And then the system calling system call is nothing but again it will be executed by the CPU only, right? So that way it's not CPU calling or whatever. Whatever is that when the user program is executing at that time, if it requires any IO device or any IO activity and all, at that time the appropriate system call will be called and that will be executed by the CPU. So as a process of that, you will get the desired information and all. Okay. Yeah,
Okay,
these
sir.
things and all, yeah, you will just make it clear slowly as you when you progress into the system and when you progress into the contents and all. Okay. Yeah. Okay. Is it fine? Can I move? Yeah.
Yes, yes.
Yeah, right. Good. So yeah, you can see here this with this you will get some clarity. I'm not saying it will be you will get ultimate thing, ultimate clarity, but here you can see that there is a user program over here and all, and the user program needs some like IO requirement, for example, or it needs some open file is required and all. So for that, actually here this user program will make use of the API. That means here the as I mentioned like Win32 or POSIX and also those are the different APIs which supports the various functions, well-defined functions, and the user program will make use of those functions to carry out the desired service and all. So here the user program will make use of the like for opening a file, for example. Here the name you don't bother actually. Here the same name is given for the system call as well as the API and all. But usually the API has a different, slightly different names compared to the system calls and all. So here it will make use of the API, and when you call the API, that means when the user program uses that API to open the file, for example. So in that case, the user program will make use of that function call supported by the API. And when that in that API, what happens is that in that API, and that API, when the execution of API is nothing but the API will supply the what system call it is required, what system call it support to be executed. And that API, what it will do is that the system call is identified by the system call number. So that API will place the system call number into the one of the CPU register. And after that, the trap instruction will be executed. Trap is nothing but it's like a specific instruction with which the user mode, the mode transformation will takes place because till that the user program is executing. And in the API, that is also user program, user level, but you need to have the system call service has to be taken care. So therefore, the trap instruction will be executed and the trap instruction will call the interrupt handler and that will do that. It will place the like the system call number into one of the CPU register and it will change the mode bit so that the interrupt handler, whatever, it just see the read the contents of the CPU register. It's nothing but it holds the system call number and then it will go to the as then it will go to the system call interface where it's nothing but tabular and in the table whatever the system call number was there it will go to that particular entry and at that entry you have the system call address is there and that address will be placed into the CPU in the program counter. Then the CPU starts execution of that the system call and all. And then the system call will be executed. And then at the end of the system call, and again it will return based on the status, whether the system call, if it is properly executed, fine, or otherwise, if there is any error, whatever, it return to the system call interface, that means API, and that API will again return will be returned to the user program and all. So that way, the user programs will use this system calls by using this API. And the API, what it will do is that the API, it will based on the whatever the system call that is required, that API will place the corresponding system call the identity or number in the one of the CPU register, and then it executes the trap instruction, and the trap instruction basically changes the mode bit. Like till that the user program is instructions are executing in the like in the user mode where the mode bit may be 0 or 1, and then when you set the mode bit, then the kernel routine or the interrupt handler will come into the picture, and then it accesses the CPU register, whatever the call system call identity, and then it will read that, and then it will access the table, and then from that the starting address will be accessed, it placed into the PC, and then the system call will be executed. So this is the way the system calls will be executed or will be handled by the normal user programs and all. And so this is by using API. Similar to that, even some high-level programming language supported libraries will be there, and they also will support the like using the system calls by their user programs and all. And this is the very well-known thing, whatever simple C program where some output statement or the input statement like printf or scanf and all. And this is a function, a library function supported by the C library. And this function will internally call the system call, will actually call the system call. So here this is the printf function. And here the job is that it has to print this particular the string, whatever is over here and all. And for that, the printf function will call it knows the system call ID of the particular function is nothing but write system call. So for the write system call ID will be placed in the CPU register, and then trap instruction will be executed. Then the interrupt handler will do the thing, will see that identity of that system call, and it goes to the system call table, and the starting address is placed into the program counter, and then the system call will be executed and all. So that way you can say here this is the printf function for that. And here the corresponding system call that will be executed will be the write system call and all. So that way the user programs will access the system calls to make use of the operating system services and all. Then coming to the system calls are nothing but software functions. So they also expect some arguments from the user, like so as we see the normal conventional functions where the function function based on the thing that need to be carried out inside the function, it needs certain input from the user and all. The same way here also, to perform a system call, the system call expects certain parameters from the user, and how to pass these parameters to the system call. There are various ways. They are a bit intuitive, not very difficult here. If the number of parameters to be passed are very limited, then you can make use of the CPU registers itself. You can make use of CPU registers itself. It means that what are the parameters to be passed, if they are limited, they are one or two or like finite, very, very limited. So in that case, those parameters will be like the API will place those parameters into the appropriate registers, and then the system call will access when the system call is executing at that time, whenever these parameters are required, those parameters will be accessed from the CPU registers directly. So this is one way of passing the parameters to the system call. The other way is that suppose the number of parameters are large, huge. So in that case, the CPU registers cannot hold that many parameters and all. And not only that, CPU registers are meant for some other specific purpose. So they are finite. You can use the fewer CPU registers, but when the number of parameters are more, at that time, the CPU registers, the way of passing the parameters through CPU registers may not be useful, may not work out. So in that case, the other way is that using the block or the stack. So block mode is nothing but, so whatever the parameters you want to pass, for example, so all those parameters will be packed and placed in some memory location, in some memory block. And then the starting address of the memory block will be placed in a register, CPU register. And then when the system call is executing, then whenever those parameters are required, then the system call will access that particular register, and the register contains the starting address of the memory block where all those parameters are present. Then from that, the system call will access the parameters. This is one way to access the parameters. And the other way is that using a stack. Other way is that using the stack. So using the stack, actually when the system call, before that the API or these library functions, so whatever they want to pass to the system call, so they will be pushed into the stack. They will be pushed into the stack. Then afterwards, when the system call starts executing, at that time, it makes use of the those parameters that are available from the stack using a pop operation. So that way, by using stack, either stack or a memory block, by using these two approaches, you can pass the parameters to the system calls and all, right? So these are very intuitive. If there are very limited, you can use directly use the registers, CPU registers. And if the number of parameters to be passed are more or large number, then in that case, we can use either the memory block or the stack. And this is the diagram way of showing that. For example, here the system called 13, where it is from here it starts executing, and at this point it needs the parameters. So then in that at that time those parameters are there at the address that are present in this particular register and all. Then it will access that. Okay, so then the different types of system calls, as we have seen, the operating system will provide the varieties of services, different classes of services and all. So for each class of service, there are to carry out their services and all. It has for supporting that, it need to have corresponding system calls. For example, in case of process control, you have these are the different types of system calls, some of the system calls here. That means first of all, you have to create a process, and then it has to terminate the process. Like when the process reaches to end, then the process will be terminated. Then end and abort, sometimes the process will be terminated because of errors, and sometimes the process will be terminated in a normal way. And then once the load and execute, loading means nothing but a program that is there in the disk is to be placed into the memory for execution. Then execution, that means starting the sequence of instructions to be passed. So likewise, these are the various system calls. Get the process attributes is nothing but set the process attributes. That by using these system calls, you can set the process attributes, like what is the priority of the process. So likewise, the different attributes you can able to set and wait for time. Sometimes the process need to wait for a certain event and all. So all these things are various system calls that are related for the controlling the process, related to the process. And similar to that, we have a file management also, because file is nothing but it's an abstract entity for for representing the information and all. It means that that information may be there in any of the devices, like a disk or like a CD or a pen drive or whatever, different physical devices. But the information will be in a uniform way. You can able to access the information using the files. So related to that, you have again system calls like creating, deletion, and opening, closing, read, write, and so on. Like with the device management, then information maintenance, like setting the time and knowing the time, and just knowing about different device attributes, setting them. So all these things like how much disk space is available and how many processors are there in the disk. So all these things comes under the information maintenance. Then the communications, we know that no process will communicate, and also for that purpose we have a system calls are required, because all these services are provided by the operating system. So therefore there are varieties of system calls to carry out various classes of services. And yeah, right, sorry, yeah. So this is like an example. Like here you can say that first column you can see that different classes of service, like a process control, manipulation, so many things. And these are the some of the example system calls supported by the different well-known operating systems like Windows and Unix and all. In case of process control, where you have the for creating a process and for exiting the process and wait for an event and all. So the system calls in the Windows operating system will be this one. And whereas in case of Unix, these are the system calls. And likewise, file manipulation, device manipulation, and so on here. And you can able to see that in case of Unix, you have sometimes you have the same system call will be used for multi-purpose, like either for file manipulation or a device manipulation. You can see that you read, and here also read, right? So same, that means almost the system call remains same. It will treat both of them as a uniform way, like for a device as well as a file. And and likewise, you have protecting the files, protecting the devices and all. You have the corresponding system called like a ch mode and ch own, like that means change the mode, like a read mode, write mode, and so on. So these are the various system calls pertain to the different operating systems and all. And so when you see the, like, so far we just covered till the basic interface and the system calls. And with that, let us see the example of MS-DOS, where in MS-DOS is basically at the initially, it is at the very beginning, it is a single tasking system. That means single user system. That means only one process, only one program will be executed at a time, right? And here in this case, the first, the shell is nothing but the command interpreter. So it will be invoked when the system is booted. That means when the system is started, first this command line interface will be invoked, right, along with the kernel. Then afterwards, here there is nothing like a creating a process and all, because only one program will be run at a time. Only one program will be run because it's single tasking. And once this program is over, then the next program will be run. So that is at a very initial point with a very simple MS-DOS system. And so therefore it has only one memory space, the total memory space it will be given for the entire program and all. So when the program is loaded into the memory, it even override the command interpreter also, because the job of command interpreter is that to run that command, so that it will bring the program. Then afterwards, then if the program requires a more memory, then it will overwrite on the command interpreter also, because once the program is there, then it will be executed. Then once the program execution is over, then again you can able to bring the command interpreter. That's what, upon exiting the program, again you can load the shell. Shell is nothing but interpreter and all. You can see here. So for example, at the beginning, you have a kernel, that is the operating system, and then the command interpreter. The command interpreter is nothing but it's an interface. And with this interface, first you will load the program. And when the program is loaded, if the if the program is larger enough, then it can override the command interpreter also. It can override the command interpreter also. And so that way the program will be loaded and it will be executed. And once the program execution is over and the program completed, it is exited, then again the command interpreter will be loaded, right? Because if the command interpreter is overwritten by the earlier process, then again it will be loaded and again the next program will be brought in. And likewise, it can be you can have the MS-DOS at the very beginning, a simple case. Then coming to the Unix system where it supports the multi-user. So in that case, actually here, since you need to run the multiple programs or you need to host the multiple programs in the memory. So therefore here we have you need the process creation is required. So that for that purpose, use the system calls like fork and exit system calls. And you can see the way it used to be. Here you have a kernel and you have some interpreter, some shell, and you have multiple programs will be there. You can have the multiple programs will be placed into the memory and all. And you can run the programs by using appropriate CPU scheduler, you can able to run. Yeah, then the next thing is that like the system programs. Yeah, now you can see that that you can able to see the distinction or the difference between a system program and a system call and user programs and all. And here the system programs, basically you can say the system programs provide a convenient environment for a program development and execution. And they can be divided into these things. So basically here the system programs are nothing but they will provide a convenient environment for a user to write a programs and execution. So it means that here you have operating system. So that operating system is will be used by the user using the system calls. And again the system calls will be difficult to use it by a user program directly. So therefore use the API, right? And then here the system programs are basically nothing but these programs are on their own. They are not they don't have the specific purpose at all, but they have the generic applicability. And with that, the user programs will use these system programs in their user programs to use the operating system and all. For example, simple thing earlier, as I mentioned that suppose you want to perform a copy contents of file from source files to some destination file. And for that purpose, when you look at that, the sequence of system calls, you have several sequence of system calls that need to be traversed through for completing the copying the contents and all. And suppose if you want to write a user want to write a program and all, so he has to call those system calls, right, one after another and all. But even though he may not call those system calls directly, but he can use those functions, the application programming functions, like, and then he has to use those functions one after another. Like for every system call, he has to use a separate API, the user defined that API supported function, and you need to use those functions in a systematic way, in a sequential way. But you need to do those things because you had to use those copying and all, like many times you had to use that. So for that purpose, for copying the file, so whatever those things, all those system calls, calling all the system calls, everything, so that everything will be put it under a wrapper, and that will be used, given for a user to use that, given for the user to use that. So for example, you have a simple CP command or the copy program, system program. So the user program can use those, the command. The command is nothing but again a program, right? The command is nothing but it's a program. It's a file where that file contains a program and all. So when the user can use that program directly, so that the execution of that program will take care about the calling the several system calls to perform that particular task. Otherwise, you see the difficult, imagine the difficulty of just copying a content of one file to other file. You need to you need to use the several system calls in a very systematic way, right? So instead of doing that, the operating system or somebody will do that, will pack all those things in a proper way in the form of one program, and that program can be directly used by the user programs and all. So that way, if it that way, the system programs are like that. Most of the system programs are like that. The file manipulation. Suppose if you want to like copy a file, you want to perform whatever, you want to create a file, or all of them, all these things requires the system calls. All these things require the operating system functionalities and all. But the user will not know about that. User will make use of the system programs. Already they are ready-made, they are available. So these system programs will be used by the user, so that the users writing a program will be, it makes very simpler and all. He need not worry about how to call the system call, how to use the sequence of system calls and all. He need not bother about that. So that way, the system programs are nothing but they are kind of a bit generic, and these system programs are basically call the operating system routines or operating system functions to perform the activity and all. So that way, since you can say that the operating system will perform varieties of services and all. So to handle that, to take care of that accordingly, you have the varieties of system programs for various activities. For file manipulation, you have some set of system programs are there, and system information monitoring or like the programming language support and program loading and execution, communication between the process, application programs. For all these things, we have the varieties of system programs that are available, and the users will make use of those system programs to access the operating system or to access the services of the operating system and all. So is it clear now? Actually, because so far you have confused with the system program, application program, and the system calls, operating system and all. Is it okay?
Yes, sir.
Yeah, right. No, because the system programs are nothing but you just think the system programs are is kind of a generic program, yeah, a generic program which will be required like the many times or many instances of time by the user and all, by the user programs and all. So therefore, the user need not worry about that. User need not write these codes like repeatedly. Instead, he can use these generic routines or generic programs as part of his user program, so that the desired functionality will be taken care, right? So that way, these are the system programs. If you look into it, then you can. Yeah, one thing is
Sir,
that. Yeah, please.
one question, like system calls are a part of operating system, right?
Which one?
system calls are a part of operating system.
Yeah, system calls are purely the kernel routines.
What about system programs?
Yeah, that's what the system programs, they will sometimes when you say that Windows operating system and all, it has a kernel where it contains the, as I mentioned, the system calls will be there, and along with that CD also contains the system programs, the list of system programs that supports the that supports me, that basically takes care of all the generic activities of these operating systems and all. So usually the system programs are not part of the operating system, strictly speaking. They're not part of the kernel. They are like just like another user programs only. Another like other user program, but they are their behavior is a generic programs and a generic one. Like as I mentioned, like a file, just simple one, just copying a file and all. Like for that, what it require, copying a file means you need to have the source file is required. You have a destination file is required. So that was those are the two require arguments that are required. And afterwards, it takes care of that. It takes the source file, takes the destination file, and then it sees that whether the four files are existing or not. If it is not existing, it throws a message. If it is existing, then it will tries to copy the entire content of a source file into the destination file, and then it returns. So that whole thing will be done by the system program and all. So that means internally it makes use of the entire all these system calls. It just called all these system calls in a systematic way, and then wherever whatever happens, so all those things will be taken care by the system program, right? Just think about that simple copy command and all, copy system program. If it is a system program, how it used to be like. Otherwise, a normal system call means it will do each system call will do its job. Each system call will do its job. Like for example, you want to take a file name. For that, there is a system call to activate the keyboard. If the user want to enter the file name through keyboard. And likewise, for displaying that, you need to we need to that the user program has to contact the display device. So likewise, all these things will be properly packed in a wrapper, and it will be given as a program given by the mostly these programs means all these programs, they are called system programs because they very frequently use the operating system services and all, right? So that is the so mostly these system programs are not part of the operating system. And if you want, actually you can write your own system programs also, you can add to that, right? Using the by putting APIs into that, with that you can able to do that.
Yes, sir. Another question, like,
Hmm.
so system calls are usually called through APIs, right?
Yes, the system calls
What
are
about
called. Yeah,
system programs?
whatever
Are
system
they called
program,
through?
whatever system programs you are saying, otherwise.
Yes, sir. Yes, sir.
Uh, right, right. No, no. What I'm saying is that if a particular system program, suppose for example, when you're writing a program, it's not that all the time the system programs are available, ready-made, available for the user to use that, right? So in that case, suppose if you want to perform certain thing where it has to be used by the operating system service, and for the particular system call system program is not there, then he will make use of the API function, and with that function he can call it. He will use the make use of the operating system service. And as I mentioned, like the frequent the programs are frequent services that are required by the operating system. So that will be carried out by the service, the system call and the sorry, the system program and all. And again, these system programs will internally use the API. Okay, they don't call the system call directly. They also make use of the API inside, because the system call, system programs means they again they will write with some high level language, and the high level language they will make use of a particular API, and with that they can access the calls and all. So yeah, right. So now I think yeah, it's time now. I think 11:40. So we will yeah, stop over here, and here these are the system programs, and you can see these are the varieties of system programs that depends upon the file management and so on. So we'll maybe yeah, maybe what I can do is that actually here yeah, mostly we had done this one. So what I will do is that in the next class, because we are missing the 26th class and all, so what I do is that I will record the rest of this chapter and put it in the net, so that for the next class you have a test on the this one, whatever we have done after that, after the previous class lecture and all. Okay, right? Because now we had to go into the actual part of the operating system, the more detailed one. These are the introductory thing and also anyway, I will do the later on from the system programs onwards. I will record it. I will place it into the this one in the Teams and all. You can access that, and then we'll have a test on February 2nd on these things, like starting from this one, the previous recorded in chapter. There is a part of chapter 1 and the part and the chapter 2 complete. Those two, these things will be part of your test, part of your next quiz and all. Anyway, I will just mention in the your email also if required. So we'll stop here, and now you please go to your yeah, you try to access the, where is that? Yeah. Yeah, you can try to access this one. Yeah, I already posted the quiz and all. So the way you had done in the last class, please do that. And it's a very simple quiz, and so it will not take much time and all. But even then, since it's the very beginning, so I gave more time. Actually, 15 minutes I have given, and it's just 10 questions only. And so all are multiple choice. So for this test, maybe later on I can introduce the other some like numeric or some small answers like one word or one sentence kind of a thing. And this particular quiz is multiple choice, right? And please try to access that. I have given 15 minutes time. It's beyond the more than the requirement and all, because it's just multiple questions, multiple choices and all. So please answer that, and we'll meet on the on 3rd and 2nd February. On that day you have a quiz also. Quiz, and the contents of the quiz are basically that. So whatever is covered under the quiz one is not included, right? And then again, I told you that I will record a video of the remaining part of this particular chapter, and I'll place it on the in the Teams. You can download it or you can view that. Or the slides are there, or in the textbook also the content was there. You please go through that. So with that we complete the introductory, and afresh in February you can start the next chapter, processes and so on. Okay. Yeah. Please try to access the. Yeah, still time is there. It's 11:40 only. Yeah.
Sir, one clarification.
Yeah, please.
Like the quiz will be held like every week or every once in 2 weeks?
No, every week actually. Every week.
Every week.
Yeah, almost every week.
Okay, sir.
Yeah, every
Thank
week,
you, sir.
and then the quiz. I just, because you see that this is one way, it will be easier for you also, because it's almost like continuous evaluation. Whatever is covered in the class, so that will be there. But just I'm adding slightly more here in the introductory thing, because otherwise, no, it takes a lot of time. You can see almost like a month is over with the introduction itself, right? So that's the reason that I'm just recording the video. But later on, as far as possible, we'll try to see that whatever the content we covered in the class, so that will be there. But for this, it will be like, for the next quiz, it will be slightly entire chapter 2 and a part of the chapter 1 at the end, right?
Okay, sir.
Yeah. Okay,
Thank you, sir.
fine.
Thank you,
Yeah,
sir.
yeah. Right. Good.
Sir,
Yeah, please be in the Teams actually, so that
sir, two videos are not
yeah.
playing. Sir, two videos are not playing.
Mine, 2 videos.
Yes, sir. 12th Gen A and B part.
Which one? 12 A, B. They're not playing.
Yes, sir.
Where are they? No, I don't know actually. Let me check actually, because.
So you can stop the recording for today also.
Yeah, I had to stop. Right.
And can you take the attendance right now also, sir?
Okay.